Hello everyone, welcome back to your channel. So how are you guys? So in this session we're gonna discuss about the lesson name is not given here, right here. Force and laws of motion. And laws of motion. So this is our lesson which is ninth standard CBSE, NCERT and foundation course included in this PowerPoint. So all those topics are covered in this chapter in one short lecture. So don't forget to subscribe our channel, like, share this video to everyone. So firstly we're going to discuss about what is force. It's the main theme. What is force? The cause of motion and change. Means what is force? A push or pull. Here also given, yeah. A push or pull, we call it as force. Here given, and can change on the objects. What has happened? What is the effects of force? Can change on object's state or rest, state of motion, direction, shape. If the object moves in this direction, the force will change in its direction into this direction, and shape also change with historical shape also change, sizes also change. It's effects of force. These are the effects of force. What are the definition for force? A push or pull. It's a simple definition and the cause of motion and change. Nextly, balanced force and unbalanced force. So let understanding this, we're gonna firstly discuss about what is net force. Means if I'm gonna apply 10 Newton here, it's a bar, it's a box. I apply 10 Newton and 10 Newton. What is the net force? 10 minus 10, 0, yeah. So where the net force is 0, then we call it as balanced force. Where here, nextly second, apply 10 Newton and 20 Newton. 20 minus 10, what is 10 Newton, right? So 10 Newton is applied. So what is the net force? 10. So in which conditions the net force is not 0? It's not 0. Where is another number, so we call it as unbalanced force. Where balanced force is rest and unbalanced force, there is some motion is there. These are the two types of unbalanced and balanced forces. Nextly, by Newton's law. Nextly, our topic is Newton's law of motion. You know what? Who is a scientist? A famous scientist called Sir Isaac Newton. He gives 3 laws for laws of motion. He gives 3 laws. Newton's laws of motion. He given 3 laws. So what are the 3 laws? Behind he giving those 3 laws, firstly Aristotle named scientist, he do experiments and he knew what is the natural state of an object, be rest. Firstly Aristotle said that the natural state of an object is rest. Nextly next scientist came Galileo Galilei, and he do some experiments and conclude that the natural state of an object be motion in a straight line. Nextly, Newton concluded that lastly by an apple tree, or all those are circulatory motion. Means the natural state of an motion is circular path. So these 3 concluded he about these experiments, and some experiments he concluded 3 laws. Firstly, Newton's first law of motion. Rest stays at rest, and here motion stays at motion. Okay, yeah. The law of inertia. You know that Newton's first law is also called as law of inertia. Firstly, what is the Newton's first law? Explains that an object at rest stays at rest, an object in motion stays the same speed with the direction unless an external unbalanced force or unless acted upon unweighted by unbalanced force. So what we conclude here? An object stays at rest or motion in a straight line unless an external unbalanced force applied on it. So what we conclude here, if an object, or example I take a football, it stays at rest unless an external unbalanced force, means the net force is not 0, which is the force acted, means a kick is given by a player, then the ball is start moving. So what we conclude here, the ball stays at rest unless an external, which is the kick applied on it, So nextly, The bar is moving with a uniform speed in a straight line unless an external unbalanced force applied on it. Means another kick is given when it changes its speed, or it's going to be rest. So right, it's these are the example for first law of motion. What is inertia? Okay, inertia is directly depend on a mass. It's an important point. And mass. Inertia means the tendency, note down this definition, that the tendency of an object to be at rest or motion in a straight line unless an external and balanced force applied on it. These two are related, but these two are not same, but these two are interrelated. Okay, key concept of inertia means, if we're gonna take an example, that 25 kg object and 5 kg object, which had these three, this is object 1, this is object 2, and the among these two objects, which has more inertia? Absolutely 1. Why? How we can say that? It's simple, guys. Where it had more inertia, then it had more, what, more mass. More mass, where there is more inertia, because the inertia is indirectly proportional to mass. Yeah, right. So these are inertia and mass. Before I said that the measure of inertia by mass only. Inertia is the tendency of an object to resist changes of its state or state of motion. Nextly, mass is a measure of inertia. It's important points. Keep it a note. Once again said, and here, less mass, less inertia; more mass, more inertia. Nextly, Newton's second law of motion means the acceleration of an object is directly proportional to the net force. It's not a critical method, but I can say a simple definition for that is, okay, right, 1 second, yeah, pen mode, yeah, right. Second law of motion, firstly I say that means the force which is required for motion, is directly proportional to mass and velocity, which here we introduce a new physical quantity called, what happened to this, yeah, okay, right, another physical quantity we're gonna introduce here called momentum, which is denoted by P. Momentum equals to mass into velocity. Means what we conclude here, which is the force required for an object to get into motion, which is directly proportional to mass into velocity. We know what is mass into velocity. We know that mass into velocity equal to P. So momentum. So force is directly more proportional to P. Yeah, right. This is about second law of motion. Nextly, formula F equal to ma. What we know that force equals to ma. Force equals to mass into acceleration, whereas momentum equals to mass into velocity. It's a key difference. And F is equal to net force and Newton mass. Here a diagram given about that diagram. F is equals to ma. It's okay. Yeah, guys, you wanna see here? It's image of that. Yeah. 1 second. This image which is there here given, and once again, more force, more acceleration, faster. Why it is more force, more acceleration? Means P equal directly proportional to F, means momentum is directly proportional to force. Then the more momentum, then more force right now. Okay, more mass, less acceleration. Means what we know about inertia is inversely proportional to this. Yeah, right. Okay, all okay. Okay, here we all know that momentum, which is denoted by P, the power of motion, defined as mass in motion, depends on object velocity and mass. It's a vector quantity. It's a important point, that vector. What does it mean by vector? Which consider both direction and magnitude. We call it as vector quantity, whereas here momentum is a vector quantity. Formula for momentum equals to P equals to me, mass into velocity. Here unit is also given, kg meter per second. Kg meter per second would we call this as kg meter per second. Okay, yeah. Nextly, here less mass, high velocity. What happened these? Okay, more mass, less velocity, because they're interrelated. There's more mass and less velocity, or less mass, more velocity. It's a momentum. P is equals to me. Okay, right? It's all about that. It's a physical quantity. Momentum is another physical quantity. Nextly, Newton's third law is very interesting, guys, that For every reaction there is equal and opposite reaction. This is a simple Newton's third law is that if we push an object, it again pushes with that same velocity, okay, with that same force. For every action there is equal and opposite reaction. Forces occur in pairs, means force occur in two different bodies. Forces occur in act on different objects. No cause of effects or happen seamlessly. This is all about Newton's third law. If a collision, means I'm gonna explain by this. Cars, if I apply 10 Newton, then this car also apply 10 Newton. This is the Newton's third law. Simple. Every reaction there is equal and opposite reaction. Next, conservation of momentum. It's a simply I say that I can write here, note down. What is law of conservation of momentum? What is law of conservation of momentum means? Momentum, I can write momentum as P. Momentum before collision of an object equal to momentum after collision. Means collision means if an object, two objects are collide each other, means attract each other or defend each other, or means push each other. So what is the here touching point, which is the attracting point or a collide point, which is there after they move continuously. If I'm gonna apply so momentum before collision, moment after collision is equal. How I can draw these two objects M1 and M2, which is collide each other. M1 M2 collide each other, and again they started moving like that only. M2, which is the V1 velocity, U1 velocity, and here V1 velocity, and here U2 velocity, V2. The velocity is changing, but the momentum before collision after collision is same. Equation, I am writing equation that momentum before collision means M1 U1 plus M2 U2 equals to M1 V1 plus M2 V2. This is the equation. For note it down. For derivation you can comment on it. For that derivation I can make another video for that. Okay. Next is the total momentum before collision or interaction equals to the momentum after collision interaction. Before I said I write point here. Nextly, total momentum before, total momentum after equals. It's equal. Yeah, formula equals to initial. Your formula given, guys. Okay. So write m square. It's not equally, but you can use this equation, which is very simple and easy to write. Yeah, of course. Okay. Yeah. Okay, guys. Types of forces. Let me gonna. Oh my God, screenshot is happened, guys. Okay, all right. What happened? Yeah, only one topic left. That types of forces, we want to know the contact force and non-contact forces. Not collision noise here, not contact forces. Contact forces and non-contact. Contact means which is contact for muscular. Means non-contact means which is not contact. Contact force is muscular force, frictional force, for tension force, air resistance. Non-contact magnetic, electrostatic, and gravitation force also come under this gravitational force. Here this is electrostatic force, this is magnetic, these two are magnetic force. Electrostatic force, apple fell down, which is gravitational force. This is a muscular force. These two are because of physical contact is there. Yeah, right. Summary. Key laws: a push or pull, change in the Newton's third law. Okay, summary, all about this summary. Physics is everywhere, guys. Physics is everywhere. Yeah. Okay, guys. Thank you very much for seeing this video. I hope this video is very useful to understand better about this force and laws of motion of chapter class 9. Not only for chapter, for class 9, which is very useful to all students which they want to listen about physics. Physics is not complex. Physics is very interesting to learn, which is keep this in your mind. Okay. Any questions, guys? Any questions? you can comment on it. I can feel free to ask. Okay, comment any questions on this or any doubts. I mean questions mean doubts. Any doubts you can comment, and you can be comment. I can try to make a question and answer session for your doubts or any hard questions, complex questions. Okay, so don't forget to subscribe our videos, guys, or subscribe to our channel. Sorry, videos, not channel. So like, share, subscribe, like, share, subscribe our videos, and prefer our channels to your friends, and share our videos to your friends, which is very useful and easy to learn. So we had an idea to make facts, which is educational facts also. If you support us very well, so we can try to make that.